Right, so identifying the three possible outcomes of a linear system. So we're jumping into more than one line. That's what a system is, more than one. You've just spent 3 days graphing lines. Now we're going to graph two together on the same graphs. So what is a system? More than one equation. What is the solution we're looking for? The intersection point of the lines. And you're going to see these three different scenarios popping up. You're going to find intersection points. So like this had one intersection point. There it is. These have no intersection point. So we just say no solution. They're parallel. And this one, you can actually have the same line graphed on top of itself. Sometimes when you solve one equation, oh, that is the same equation as that is. You know, over here, you've got two different equations here, but when you solve them into slope-intercept form, it might be the exact same equation written twice. So in that case, the solution is called many solutions because every point on the line will work in both equations. So sometimes you'll have one solution, sometimes you'll have no solution, and sometimes you'll have many solutions. Right. Yeah. Okay, so let's look at number one together. So I'm jumping into a harder problem because neither of them is set up in graphing form. I guess the second one is standard form kind of, but I'm going to put this into slope-intercept form by dividing by 2. So I've got y equals 4x minus 9. So that is now ready to graph. And the second equation, how would I get y by itself? Those of you who need some solving for the variable review. So how would I get y by itself? Start by, yeah. Right, so we're subtracting 3x on both sides. So I have negative y equals negative 3x plus 7. So I moved this as a negative 3x to the other side. My last step, I have to divide through by negative 1 to get the y by itself. So now I have positive 3x, but I now have negative 7. So these are the two graphs. Do you notice anything about them? Are they the same line or are they parallel? No. So I guess we're looking for the intersection point, right? They should intersect somewhere. So we're going to go to negative 9 on the y-axis. And this has a slope of 4 over 1. So up 1, 2, 3, 4 over 1. I like putting a few points on the graph. 1, 2, 3, 4 over 1. It kind of makes it easier to find the intersection point. 1, 2, 3, 4 over 1. If you want to use a ruler, go for it. They're over there in that bin. You could even, I know, maybe I will leave one in each. Okay, see how you, oh shoot, I didn't, okay. So there's my answer to number 1. We put them in slope-intercept form, and then we graphed the two lines, starting at negative 9, up 4 over 1, starting at negative 7, up 3 over 1. I used the ruler and then found the intersection point at 2, negative 1. And now they're trying 2, 3, and 4 on their own, and then we're going to check our answers in a minute. Video here. So in number 2, when you solve the second equation for slope-intercept form, you end up still getting 3x as your slope and then a different y-intercept. So 3x minus 7 compared to 3x minus 5. So when you graph them, they are parallel. So there is no solution for number 2. So make sure that you actually write no solution, not just parallel or don't write anything. And then on example 3, kind of a different strange scenario happens. When you solve it for y equals, you end up getting identical equations to the bottom equation. So when you graph it, it's graphing on top of itself. So you need to write many solutions, or you could write all points on the line, because all the points on this line will satisfy this line because they're the same. And then the last one, I did my vertical line at 5 and a slope of negative 1, starting at a y-intercept of 7, and I got 5, 2. And we're not going on to do the graphing and guided practice of 114, only 113 for tomorrow. Thanks.